Hello kids! Let's continue discussing about electricity. Yesterday, you have learned about what is an electrical circuit, and we said that it is a circuit for electricity to flow around. You also learned about the three parts of a simple electrical circuit, namely the electrical appliance, the electric wires, and the energy source. Now, let's discuss about the types of electric circuit. For this video, I am going to talk about the four types of electrical circuit which are. Now, let's discuss about the types of electric circuit. For this video, I am going to talk about the four types of electrical circuit which are the closed circuit, open circuit, series circuit, and parallel circuit. Let's talk about them in pairs. What is a closed circuit? A complete circuit around which current flows and an appliance works is called a closed circuit. The switch is closed. While open circuit is a circuit in which the switch is open and current does not flow to the appliance is called an open circuit. Let's watch this video.
Closed and open circuit. If you see both the wires are connected to both the terminal, it is an unbroken path. It is a closed circuit. Disconnect one of the wires. You will find that the path is broken now. Also, the bulb doesn't light up since electricity can't flow through this circuit. A broken path is known as an open circuit.
For a simple electric circuit, all you need to do is to connect the positive and negative terminal of the battery to the screw-thread contact and the electric foot contact of the bulb using electrical wires. The circuit should look like this. You will notice that upon connecting the battery to the bulb, it will immediately light up. This is because the electrons can continuously move from the battery to the bulb. This is also an example of a closed circuit. Now observe. If we remove one of the wires on any of the contacts on the bulb, the light on the bulb immediately turns off. This is because the electrons can no longer flow because the path it should be flowing was cut off. This is what we call an open circuit. An electric current flows only through a closed circuit. If the circuit is broken, the current will stop flowing. This is where a switch comes into use. A switch may be used to open or close the circuit. To add a switch on a simple electric circuit, we will attach the switch to one of the wires connecting the bulb to the battery. The complete setup should look like this. If we turn the switch on, the bulb will immediately light up. And if we turn it off, the light will immediately turn off. Thus, we always use a switch on our lights at our homes so that we do not manually cut the wires or reconnect it in order to turn on and off our lights.
Great! Now what is all about series circuit? Light bulb connected in series means the light bulbs are connected end to end in a straight line with no splitting point. In this type of circuit, the electric current flowing through each bulb is the same. While parallel circuit, light bulb connected in parallel means the light bulbs are connected across each other and across the energy source. Here, the electric current can flow in more than one path, so if one light bulb is removed, current stops flowing to the path alone, but Other light bulbs will still shine because current still flows to them. For you to understand better, let's watch this video.
Electricity will only flow on a closed circuit, such as the one shown on the screen. Notice that the electrons flow through the wire and each of the bulbs before they return to the battery. If one of the wires breaks, a gap occurs in the circuit and all the lights go out. When lights are lined up one after the other on a circuit like these lights are, it is called a series circuit. The problem with a series circuit is that when one light burns out and its filament breaks, it creates a gap in the circuit. All the lights go out because electricity won't be able to flow to the other bulbs. This problem can be solved with a parallel circuit. In a parallel circuit, the wires that are connected to light bulbs run parallel to each other rather than having all the bulbs in a row. This means that one light can burn out or be removed, and the other lights on the circuit will stay lighted. For example, if we remove the light that is closest to the battery, the other two lights don't go out because each light is connected in a way that the electrons have a complete path to travel to the positive side of the D-cell battery.
Now let's learn about the electrical circuit symbols. We learned that simple electrical circuits have three main parts, which are the energy source, electric wire, and the appliance. For easy understanding, simple electrical circuits are always drawn using symbols. So here are the symbols. First, we have electric cell. It is the energy source for the electrical circuit. When a battery is used, it is shown as many cells connected together. So, this is a symbol for one cell, and this is a symbol for 3 cells or battery. The longer line shows the positive end, and the shorter line shows the negative end. Next, we have switch. Switch. What does the switch do? It controls the electrical circuit. Closing the switch gives a closed circuit. Opening it gives an open circuit. Appliances work in closed circuit. Now, this is the symbol for closed circuit, and this is the symbol for open circuit. The next one is light bulb. What does the light bulb do? It changes electrical energy into light energy. So we have two symbols, this one and this one. But for this activity, we are going to use the former one. Next, we have the electric wire. What does the electric wire do? It connects the appliance to other parts of the electrical circuit. It connects the appliance to the energy source. So a line like this is a symbol for electric wire. Next, we also have the buzzer. Buzzer. What does the buzzer do? It changes electrical energy into sound energy. Class, a buzzer is a device that provides an audio signal in a circuit when a voltage is applied to it. Some buzzers are now used in switching sounds of electric home appliances such as microwaves, washing machines, calculators, smoke detectors, and telephone ringers, and many more. So class, this is a symbol for buzzer. And for the last one, we have the motor. What does the motor do? It changes electrical energy into mechanical energy. Class, a motor is a machine that converts electrical energy to mechanical energy. In other words, the electrical energy is a battery and the mechanical energy is the rotation. So class, this is the symbol for motor. So again, these are the electrical circuit symbols. We have the battery or the cell, the wire, the light bulb, the buzzer, the motor, the open circuit, and the closed circuit. So now let's proceed to our activities. Please open your book to page 93. It says here, study the picture and answer the questions. We have here a picture of a simple electrical circuit. First, we have to identify the parts and answer the following questions. So, number 1 is a light bulb. Number 2 are electric wires. Number 3 is an electric cell. Now, you have to write the functions of these parts. Let's start with number 1. What does a light bulb do? Since number 1 is light bulb, let's say, what does light bulb do? What does a light bulb do? It changes electrical energy into light energy. What about number 2? What does part 2 do? What does part 2 do? What does the electric wire do? It connects the electrical appliance to the energy source. And for number 3, what does part 3 do? Or what does an electric cell do? Of course, it gives out electrical energy. Now for number 2, study the diagram and answer the questions. This is all about the electrical circuit symbols. So, what do these symbols show? A line shows blank. Is it a motor? Is it a buzzer? No, it is the electrical wire. What about this symbol? Is this the light bulb? If you said yes, then you're correct. What about this one? We have 2 cells. This is the electrical cell. Now let's proceed to number 2. Does the diagram show a closed or an open circuit? We are talking about this diagram. Is this a closed or open circuit? If you said it's closed, then you're correct. It shows a closed circuit. For number 3, study the simple electrical circuit and then draw its circuit diagram. This is the picture, and we can see 2 bulbs, 1 switch, the electrical wires, and 2 cells. So how do you draw that using symbols? You can pause this part to finish your drawing. Please turn your book to page 104. Page 104. If you're ready, let's begin. In which circuit will the light bulb shine brighter? Why? So we have here 2 circuits which are illustrated using the symbols. Circuit 1 has 1 bulb and 1 cell. Circuit 2 has 1 bulb and 2 cells. So which do you think will shine brighter? Is it circuit 1 or circuit 2? If you said it's circuit 2, that's correct. The light bulb in circuit 2 will shine brighter than circuit 1. But what is the reason why? Because of the number of cells. Because there are 2 cells in circuit 2 and only 1 cell in circuit 1. For number 2, study the circuits and answer the questions. Again, we have 2 circuits here. Circuit 1 is a parallel circuit and circuit 2 is a series circuit. First question, are circuits 1 and 2 the same? Yes or no? If your answer is yes, you explain why. If your answer is no, explain why. Again, are circuits 1 and 2 the same? Of course, they are not the same because circuit 1 is a parallel circuit and circuit 2 is a series circuit. Now for number 2, if bulb A is removed in both circuits, will bulb B still shine? If bulb A is removed in both circuits, will bulb B still shine? Yes or no? Bulb B in circuit 1 will still shine because electric current still flows into it. But bulb B in circuit 2 will go off because electric current will not flow into it. That's the difference between a parallel circuit and series circuit. Now class, you can now check your drawing if it's correct. Class, there will be no homework for this video, but if you're done answering your activities, don't forget to take a photo and send it to the line group. That's all for today. Have a great day and goodbye.